Okay, good day, good people. Let us look at the hot roll and make some understanding about the hot roll. Now, on the hot roll, this is what we are talking about. We are talking about the steel table. This one is a hot roll from the book of our books, but I did show you the hot roll that we'll be working with. Okay. Now, I'm having an eye profile here. Okay, this eye profile, it has dimensions. Okay, now the first letter of this dimensions, it is the height of this eye profile. It is the height. Then the second dimension, it is the base. This is your height, and this is your base, and this is your density. Right, it's your density. Okay, now when given a, a beam and its profile, you will then have to go to the hot roll. Now, even if we are given this dimension, like I said, this is your height, this is your base, and this is your density. You're not going to use this height, you're not going to use this base. You must go to the hot roll and use the given height of this beam on the hot roll or the steel table. For instance, this is the beam that I'm looking at, 4, 5, 7, 10 times 1, 9. The density. Now, the density, it is the one that will indicate for you now which properties of an eye profile must you use, right? For instance, you can tell that here I'm having this size of the eye beam, but I'm having different densities. Now, it doesn't mean that when you see these numbers here, then you can work with any eye profile. The density will indicate to you which profile must, which dimensions must you work with. For instance, in our case, we have to use this density, 67.1. Now you go to your hot roll. These are the given dimensions, the size of your eye profile. This is the density. The density indicate for me. I can't use this details here because the density is bigger than that one. I can't use this one or that one. I'm being indicated that I need to use this density, the eye profile of that density. Now, the given height of this beam, it is 5, it is 4, 3, it is 453, comma 6. That is the height. Then the base of this beam, it is 1, 8. The base of this beam, it is 189, comma 9. Right, then you are given the thickness. The thickness, check where they've indicated to us the thickness. This is the thickness of your web, and it is given as 8,5. Then we are given the whole area of that eye profile. The whole area of that profile, it is given as 8,552, 10 times to the power negative 3. You are indicated that your area, it is to the power negative 3. Then when coming to the moment of inertia, you are, here's the column here. You are given the column of about the axis. Then you know that this one, 294,1, it is your IXX of that eye profile. 294,1. It is raised to the power of what? Negative 6. 10 times 10 to the power negative 6 m. Here's the SI unit there. Then the second column here, it is for the Z section modulus, okay? But we're not going to use the section modulus here. We will be using the section modulus in most cases to select the profile of the beam, but it's one question that we will deal with it later. For now, can we ignore the I, the Z, and this I? Can we ignore them for now? We will use them later. Then you are given as well the IYY, the IYY about the axis YY. Can you see that? About axis IYY. That means the IYY, it is given. It is 14,52 10 times 10 to the power negative 6 m quad. Now, already here they've calculated for you the IXX and the IYY. There's no need for us to do what? To calculate them as we did in the previous topic, okay? Now, when coming to this, it is given on the steel table. The height, like I said, it is given as 453, comma 1. Okay, I think it's comma 1 there, or 6, I don't know. Then the base, it is given as 189, 9. Then we are given the area. There's no need for us to calculate it. We are given 8552 10 times 10 to the power negative as our area. Then we are as well given the thickness of this where the thickness is the web. It is given as 8,5. Then we are as well given the area. It is 8,552. Oh, I've already written the area there. Now, this information, or we are as well given the IYY. It is 14,52 10 times 10 to the power negative 6 m quad. We are given the IXX. The IXX, it is given as 294,1 10 times 10 to the power negative 6. Now, when we are calculating, let's say we are having the compounded beam, okay, the compounded beam, or even this one, they want us to calculate the total moment of inertia, IT. The IT. Now we know that the parallel formula, it is I1 plus area 1 R squared 1 plus I2 plus area 2 R2 squared. Now there's no need for you now to calculate the IXX. You're gonna take it as it is and put it there. There's no need for you to calculate the area. You want to take the area as it is and put it there. The only thing that you need to calculate, it is the R, distance R. We know how to calculate the distance R. It is R equals to Y centroid minus Y1. Then we get what? The R. This one we need to calculate. Even if we are using the steel table, the R we need to calculate because it is calculated from Y centroid. Now we have to calculate it. Now the hot roll makes it easy for you to substitute the IXX, make it easy for you to substitute the area and so forth. Yeah? That is why we will be using what? The hot roll. Okay? That's how you read your hot roll, good people, and this is where we're going to use our hot roll as well. Okay? Now let's look at how we said how to calculate the IXX and the IYY of a simple beam like this one. Okay, we said it that if we are taking moment about axis XX, if this is where we are taking moment, you can tell we've taken moment where at X axis. If we've taken moment at x-axis, then we are calculating for IXX. Now, how do we calculate the IXX? We said it that if this is where you have taken moment, you start with the letter opposite to where you have taken moment. This is where I've taken moment. I'm opposite to what? To B. That means it will be B. Then you will cube what? The depth of the beam, the length of the beam. And the length of the beam, it is on what? On the Y. This is your X, this is your Y. Then it will be D cube divided by 12. We said it that this is how you calculate what? The IXX. Now, let's say this time around, we take moment. This is where we are taking moment about axis YY. Now, that means this is where we have taken moment. If this is where I've taken moment, where I've taken moment, I'm opposite to what? To D. That means it will be IYY equals to DB B cubed divided by what? By 12. Then we get what? The IYY. This information, it is this information here on your hot roll. Ne? That's that information, okay? Now, the very same beam that we are looking at, let's now rotate this beam. We are now rotating this beam. We want to calculate the IYY. Remember, we said it that in this position, the IXX in this position, we said it is BD cubed divided by 12. Then we said the IYY, it will be D B cubed divided by what? By 12. Now let's now rotate. Let us now rotate this beam. Let us now rotate this beam. Let us now rotate this beam. We are now rotating this beam. We are now rotating this beam. Oh. Boom. Okay. We are now rotating this beam. Now it come on now. This is our D. This is our D. Our D, it is on the longer side. Then our B, it's on the short side. Boom, we've rotated our beam. All right, we've now rotated our beam. Now let's take a moment here at x-axis about axis xx. If this is where we have taken moment, we are determining what? Ixx. We always start with the letter that we are opposite to. If this is where I've taken moment, I'm opposite to what? To D. Can you see that? I'm opposite to D. Let's write it nicely. I'm opposite to what? To D. Okay. If this is where I've taken moment, if I've taken moment at x-axis, I'm looking for x-axis. I'm opposite to what? To D. That means I will start with D. It will be D. Then I cube what? B. It is D. B cubed divided by what? By 12. Then if I'm taking moment about axis yy, I'm looking for what? For IYY. I've taken moment here. You will always start with the letter that you are opposite to where you have taken moment. I'm opposite to B. Then it will be IYY equals to B D cubed divided by what? By 12. Can you see that? When we have rotated our beam. Now check this. This IXX, is it not the same as the IYY in the first format? The IYY, is it not the same as that in the first format of your beam while it was rotated? Can you see that? Now that means in this position, the strongest side of this beam, it is here on IYY. Then the weak side of this beam, it is here. Why? Because the first format, we said it that it is the strongest side of your beam. Then this is the weak side of what? Of your beam. Now the weak side of your beam, it is the same as the IXX in what? In this position. Can you see that? Now let us then look at the given. Let us look at the channel. Let's say you are given the channel. This is your channel. Okay. This is your channel. Right. I'm having, this would be the base of the channel. This would be the height of the channel. The height of the channel. Then I'm having the thickness of the channel. Then I'm having the AY of the channel, the centroid of the channel. Now, when you write your channel, it will be height. This is your height here. Base. IXX. Then IYY. I'll just limit myself to this. Now let's go to our steel table and look for a channel. Right, I have channels here. Let's take the first one. 80 times 45 multiplied by the density. It is 8,64 kg per meter. Now let's look on the first column. The first column, we are having the height there. It is given as 80. Then we are having the base there. It is 45. Then we are having the thickness there. It is 6. Then we are given the area there. It is 1,102, 10 times 10 to the power negative 3. Then we are having the centroid of that channel. It is 14,5. Then we are having the IXX. The IXX, it is given, there it is. It is 1,059, 10 times 10 to the power negative 6. Then I'm given the IYY. The IYY would be the following. Column 0,1936, 10 times 10 to the power negative 6. Now, based on the information on the hot rod, we said the height there, it is 80. Base there, it is 45. Then we are having the IXX there as 1,059, 10 times 10 to the power negative 6. IYY, it is 0,1936, 10 times 10 to the power. Now, you can tell from the hot rod the position of your channel. This is the standard position of your channel. Now, when you write your base, your height, you will write them as per, as per the standard position from your periodic from your steel table. Okay, when you are given a channel like this, for instance, let's give you the picture. We are given the channel. This is the channel. Then we are given a flat plate. Then we know that the information that we need to use in calculating the IXXT, we know that it will be I1 plus area 1 squared plus I1 plus area 2 R2 squared. We know that the I, if this one we make it our area 1, we know that the I for the channel, we will take it as it is on the steel table. We take this value, we put it there. We take the area from the steel table and we fix the area on the steel table for this channel. Area, it is 1,102, 10 times 10 to the power negative 3. We take this area, we put it there. Like I said, the only thing that we need to calculate, it is the R, because R, it is calculated from YC minus Y1. We then have to calculate our R. Then in this case, on the flat bar, this is your D, this is your B. Then we need to calculate the I. It will be dB cubed divided by 12. Then we take the value that we would have calculated here, we put it there. Then in calculating the area of this flat bar, area, it will be D multiplied by B. Then we get what the area. We take the value of that area, we put it there. Then the R, we have to calculate it using that formula. Can you see that? Right. Now, if now your channel, it's been rotated. Look at this. Your channel, it's been rotated. You are having now the height there. You are having the base there. Can you see that? It means now the standard position, base, height, IXX, IYY, and XY. If this is where you have taken moment in this position, opposite over, now you can tell now that your base, it is your height. Then your height, it is what? It is your base. Then your IXX here, it will be the value of your IYY. The value of the IYY, it will be the value of the IXX. How so? You remember that which we did here. That which we did here. This concept here. This concept here. This concept of this beam. It's exactly the same concept here. You are having a beam in this position. It is B D. You are looking for IXX, it will be BD cubed divided by 12. Now, when you rotate that beam, now you are having the beam rotated in this manner. It is D B. Still, you are taking moment where at X axis. Now, it is X equals to D B cubed divided by 12. Like I've explained that this, in this position, like I've explained here, like I've explained, the IXX on the first position, remember these values are of that position, the first position of that beam that we dealt with. It was this way before we rotated it. These values are for this ones, for that position. Now it's been rotated. Look, the IYY, it is the same as the IXX. The IXX of this position, it is the same as what? The IYY. It is of the same principle as we did here. Same principle as we did when coming to the channel. The channel, it uses this principle here. If now your channel is being rotated, the IXX as per this is the standard position. This is the position on the hot roll. Hot roll. This first one, positions on your hot roll. Then these ones, they have to do with the rotation. As you've rotated what? Your channel. They have to deal with the rotation as per your channel. You can tell like this, it's your standard, hence I wrote the values as they are from your steel table. Then as you have rotated them, this, it is still the position. This is how the position is supposed to be. Because of the rotation, now I'm having this. Base being the height, right? The height now will use the value of the base. IXX will use the value of IYY. IYY will use the value of IXX. Now, the channel, good people, the channel, don't forget it. It is based on this concept that I've explained earlier here. Okay? That's how you deal with your channels. Thank you, good people.